Hey everybody, it's been a while since the last video. You can tell because my hair kind of went from here down to here. But I'm excited to continue where we left off last time. And so let's just dive right into it. The last time we were writing this test to simulate or like automate the register process. It kind of looks like this, let's just run it. So we're gonna type in first name, last name, email, and password and click register. And we get the error that says an error occurred because of an invalid CSRF token. Go back, refresh, and try again. Now this is just like a custom message we put in there. We kept getting this error on the server side and it would just basically send like a stack trace and it was disgusting. So quick fix, we just threw back this error. But sometimes when I run this test, I get a different type of result. So maybe we'll get it on this one. Sometimes it just says internal server error. And I think these are really like two different problems. Okay, so here we got internal server error. I kind of think it's like a couple of different problems. So my goal in this one is just to go over the CSRF issue, and then maybe we'll, in the next video, we'll just try to figure out what this error is, and we'll try to get past this test eventually. And of course, feel free to check out the previous video so that you can get a background on what that's about if you feel that that's necessary. So before we can tackle this problem from like what the error message that the test is giving us, I think it's important that we first understand the CSRF attack, which is the topic of this video. But before we do that, I kind of want to go back and make sure we have an understanding of how authentication works on the web. So keep in mind that the web is stateless, which means that on every request, you need to remind the server who you are, and you would do that by authenticating. But it would be like super annoying if on every single request, we had to send our username and password every time. So instead, what happens is we send our username and password one time, like when we log in, and then the server will give us back basically like a stamp in the form of a cookie. And then the stamp is really just like a long gibberish kind of looking string, and we call that like a session. And it's a string that you will pass back to the server on every request instead of your username and password. And the server will say, okay, yeah, I've seen that string. I know what that string is. That means that this is, that person who's logged in right now. So that's how all the requests are like tagged against your account. So what makes it really convenient is that when you send a request to some host, your browser will automatically send the cookies that belong to that host with every request. And that's super convenient, but it actually opens up the door for the CSRF attack. So let's try to understand what the CSRF attack is. So CSRF stands for cross-site request forgery, and that basically means forging a request from another domain. And it hinges on the fact that your browser is automatically sending those cookies on every request that you send to that host. So here's the attack. Basically, an evil person, say Eve, is going to get you to send money to her without your consent. So Eve knows that many people are logged in to bigbank.com, and bigbank.com happens to be vulnerable to CSRF attacks. And when you're logged into bigbank.com and you want to send money to your friend, Eve knows that the request looks something like this. Basically, a post request to the send endpoint, and you pass in like what amount of money you want to send and to which account. So Eve is going to capitalize on that information by making a really cool website called kittens.com. And when you visit that site, behind the scenes, you won't be able to see it, but she'll automatically kick off a post request to the send endpoint and put an amount like $10,000. And for the account number, she's going to put her own account number. Now, if you have an active browser session with bigbank.com, that means that you're going to have that cookie. And as soon as that post request is sent off, the browser is going to send that request along with your cookie that says that this request is authenticated or authorized by you. So obviously that's a problem. Bigbank.com is thinking that you're going to authorize sending $10,000 to Eve, and boom, off goes your money. So here's the thing, bigbank.com can prevent this kind of request by using something called a CSRF token. They only want the send request to happen from bigbank.com. So when you visit that webpage, when the server reads that visit, they will send back a token in the response. And then when you are actually using the application and you press the button to send the money, then they will send that CSRF token that's found on the page over to the bigbank.com server. Now, that fixes the problem, because when you go to kittens.com, they're not going to have that CSRF token on the page. It's going to be a random, unique token every single time, so there's no way they're going to know it. And then, obviously, on bigbank.com's backend, they're going to check, hey, did you send the CSRF token? If you didn't, then we can't authorize this request. And that's how this attack is prevented, basically. Okay, so now let's look into what's happening in this failing test and try to figure out why is this raising a CSRF issue. So I think the first thing I'm going to do, I'm just going to look for this string here in the application. All right, so it looks like we have some sort of like error middleware here that says, well, basically, if it's not ebed CSRF token, then send this, and that means that that's just like default error. But otherwise, it looks like we're going to send this error here. So it's pretty clear that we have ebed CSRF token. All right, so this ebed CSRF token error is coming from the CSRF package, which is a package that you can use like as middleware, and it helps you with getting the CSRF token to send over to the client and all that kind of stuff. And that's what's throwing the error. And if you look in our like server log, we're console logging that one, and it's clearly coming from the CSRF package. The request that we're making is to the register route. So it looks like on the register router, we have CSRF protection here. And the first thing that kind of hits me is like, why do we need CSRF protection on a route that you would hit when you're not authenticated? Remember that the whole point of the CSRF token is to prevent an unauthorized request. But if I'm not logged in, then it doesn't matter if like I go to kittens.com and the register route gets hit on my behalf. I mean, it doesn't even have anything to do with me. It's a public-facing API. If Eve really wanted to, Eve can just hit that register route a million times, and it doesn't affect me as like a visitor of that site or a user of, in this case, Skill Silo, the app that we're working on. So I'm looking at this and I'm thinking, I don't think we need CSRF protection on this route. I feel like this speaks to sort of like my inexperience, and I probably learned about the CSRF attack, but I didn't really fully understand it. And the way I'm looking at this here, I just don't think this is necessary at all. So my strategy here is going to be to remove this, and I'm going to save. And now I'm going to just try that test again, and I'll try it like, maybe 10 times and see if I eventually run into the CSRF attack, the CSRF token issue again. But I really don't think that that's going to happen, because again, we're not checking for CSRF, CSRF tokens anymore on that route. So let's see if that's the case. So let's just run it a few more times now. The server should have restarted after my change. All right, so it actually looks like we did register. We ended up on the login page. Also probably not what we wanted, but it looks like we're actually probably logged in right now. So we definitely didn't hit the CSRF issue there. And it looks like we got the same thing again. I want to just check my server. Do this. So it looks like since the last restart, we didn't have any of those like CSRF issues. Let's try a few more times. So we got internal server error. Now I kind of just like looked into that a little bit. We have something called a form delay. This is to prevent like robots from signing up on our website. And it looks like it's hitting that. So we do have a robot, like Cypress is being our robot in this case. And it seems like maybe it's getting tripped up on that every now and then. So I think that's going to be the topic for the following video, and we'll check that out. but for now, I'm going to just try to see again if we've maybe prevented this CSRF issue. So I'm going to keep running this a few more times. And now we actually landed on the dashboard itself. So it seems like we have super inconsistent behavior from the server side. I have no idea what is behind each and every one of these instances, but it looks like so far we have, aside from the CSRF issue, which I could say is like maybe that's done already, we're going to have the internal server error issue, and we have also hitting the login page, although being logged in, and then sometimes we're hitting the dashboard. So we have three different scenarios, and only hitting, like landing on the dashboard is the one that we actually want. So I think we still need some further investigation on this test. But it looks like I'm just definitely not hitting the CSRF issue anymore. So I think that's pretty good. That's really all I wanted to cover in this particular video. I may put a few links inside the description to like some other videos that explain CSRF, the attack and protection in more detail. And I think again in the next video we'll cover the rest of these test cases. The other thing that I remember that I just saw actually was, if you look in this auth router here, it looks like, so we took the CSRF protection away as a middleware from here, but it looks like if I look in the login router, we have the same thing here. So I imagine like when we move on to the login test, we're going to end up with the same problem, and we really shouldn't have CSRF protection over here. It doesn't make any sense. Not to mention that we have the error code check over here. This just seems like a huge mess. I do notice also it's on the log out router. That instance, it actually does make sense to have CSRF protection. And I actually, I remember like a few years back when I learned about the CSRF protection, I wanted to see if like other websites were vulnerable to it. So I actually did end up creating a page that if you visit it, it will log you out of GitHub, which I thought was really weird. And I thought it was kind of strange that GitHub was vulnerable to this sort of thing. I don't know if they've fixed it since then, but that's not the kind of experience that you want for your users and your app. So you really want to protect yourself, even on something as simple as logging out. But there's no reason visiting some other webpage should log me out of a different service. So I'm going to keep that CSRF protection one there. So again, maybe we'll cover the CSRF protection on the login router in a future video too. All right, that's all I got for this one. Thank you so much for watching. If you have specific things you want to see as part of the refactoring, or something that you saw during this one that you wanna go into more depth about, just write a note in the comments. Hit a like on this video if you thought it was interesting, and it really helps me to motivate me for creating more videos. So thanks for watching. I'll see you on the next one.